Okay, today we are going to be going over chapter 5, lesson 1, so 5.1. The first things is that we're going to talk about the different type of triangles we have. So the very first one is no congruent sides. No congruent sides means all three sides of the triangle are different lengths. So if I drew a triangle here with different lengths, I'll try to do my best. And if I did put in my tick marks, remember your tick marks here? To say this is one length, well, this is a different length, and this is also a different length. The type of triangle that has no sides with any same length, it's called scaling. This is a scaling triangle. Next, two congruent sides. Two congruent sides just mean there are two sides that are the same length. So here, I'm going to try to draw a triangle with two sides that are the same length. I'm going to mark them. These two sides are going to be the ones with the same length, like so. And this type of triangle is called an isosceles triangle. Finally, three congruent sides. This means all three sides have the exact same length. So I'll try to draw a triangle here with all three sides. I'll mark it with my tick marks where all three have the exact same length. This is called an equilateral triangle. Equilateral means sides, lateral, lengths. So equal lengths, equal sides. Okay, now we want to go on. The next classification is classify triangles by angles. So three acute angles, meaning all the angles have to be less than 90 degrees. That's what it means to be acute. Means that draw something like that. That means that the triangle is considered acute. If one of the angles happens to be a right angle of a triangle. So here I'm going to draw a right angle. I'm going to make my right angle mark, which is that square in the corner. If any one of the angles is right, then the triangle itself is considered a right triangle. If any one of the angles is obtuse, so if I draw an obtuse angle, and I connect them to make a triangle, then the triangle itself is considered obtuse. So if any one of the angles is right or one of the angles is obtuse, it is considered a right or an obtuse. All of the angles have to be acute in order for that triangle to be acute. And if they have three congruent angles, if three angles are congruent, that means all the angles are the same. In a triangle, they all have to be 60 degrees. But try to draw that. Then it's considered equal angular. Equal angular just means same angles. The angles are measured the same. So here, if we let's try to classify this here. I notice at number 1 that it has the square in my corner. So I know this is a right triangle. And so it's automatically a right triangle. Two of the sides are congruent, so it is considered a right isosceles triangle. So we're just going to write down right isosceles. As our answer here. This next one, I see that all the sides are equal. So there's only one type of where all the sides are equal. That means they have to be equilateral. And I notice that all the angles are acute. So this is acute equilateral. This last one, none of the sides are equal. It doesn't have any tick marks. I know I'm dealing with a scaling triangle, and one of the angles here is looks obtuse. So this is an obtuse scaling. Heading down, the angles inside a polygon, those are your interior angles. An example of that, let's say if you draw a triangle here, your interior angles, imagine if you have an isosceles, these two would be the same and this one would be not the same. So these are isosceles triangle. That is your interior angle right there. If you had a scaling, all the angles would be different. That would be one, there's another, and this would be a different angle altogether. Next one, the outside angle then is your exterior angle. And they form linear pairs, meaning remember they have to add up to 180 degrees with the other angles. So if I draw a picture here, if I draw from one side and I draw a straight line out, another side and I draw a straight line out, and then another side and I draw a straight line out, those would be my exterior angles right there. Next, the triangle sum theorem is this says that the measure of the interior angles of any triangle, so all the measures of all the angles together, added together, have to add up to 180 degrees. So you get a triangle, and let's say here's angle 1, 2, and 3. Well, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must equal 180 degrees. After that, our exterior angle theorem. The measure of the exterior of the angle triangle is equal to the sum of the measures of the two non-adjacent interior angles. So if I were to draw, for example, a triangle here, and this would be my exterior angle, we'll call these angle, okay, say this is 1 and 2, and we'll just call this one the 3, this angle number 3 right here. This is my exterior angle, this one right there. Well, I know that the measure of angle 3 must equal measure angle 1 plus the measure of angle 2. Let's try some of these out to solve for this. I know that here, number 1, I got 40 and 70. They both have to add up. All three of them have to add up to 180. So I'm going to take 180 and I'm going to subtract away 40. I'm going to subtract away 30 to find the angle measure, which is then equal to 110 degrees. Here, angle 2, remember the measure of exterior angle must equal the sum of the interior, the two that are not touching it, the non-adjacent. So here, 2 then must equal 64 degrees plus 75 degrees, which will give me, 7 plus 6, 139 degrees. Number 3, we have some variables, but the same rule applies. I know that the exterior angle, which is 2x minus 2 degrees, must equal the other angles on the inside that aren't touching it. So it's x plus 45. Now, all I have to do is I'm just going to find for x, I'm going to find x. I'm going to subtract x to both sides. This gives me x minus 2 equals 45. I'm going to add 2 to both sides. x then must equal 47. So this is 47 here. And this angle then must be 45 plus 47, right? 45 plus 47, that gives me 92 degrees. Finally here, I know that all the angles must add up to be 180. This square tells me that's a right angle, so it's 90 degrees. So 90 plus 3x plus 2x must equal 180 degrees. I'm going to subtract 90 to both sides, from both sides. And combine my like terms, so that's 5x equals 90. Divide both sides by 5. I get x equals 18. So that solves there. So 2 times 18 gives me 36 for this angle. 3 times 18 gives me 54 degrees for that angle. And that is all for today.